The year is 1940. The Battle of Britain, a conflict of high summer skies, desperate dogfights, and raw, youthful courage, had been fought and, miraculously, won high over the chalk cliffs of the south coast. Yet, the war was far from over. It had merely changed costume, shedding the daylight glare for the deep, suffocating shroud of the night. The war had gone underground, into the damp, echoing labyrinth of the tube stations of London, and upward into the thin, icy silence of the high night sky. Britain stood alone, a defiant, isolated island fortress, her defenses ringed by a continent sealed beneath the iron fist of the Third Reich. The nightly visitation of the German Kampfgeschwader, the methodical, relentless bomber wings, was known simply and terrifyingly as the Blitz. Every evening, as the setting sun bled across the channel in shades of blood and bruised purple, the air became thick with dread, and the sirens began their haunting, inevitable song. London, once a landscape of bustling commerce, transformed into a theater of sound and shadow, defined by the rhythmic, earth-shaking crump of high explosives, the desperate, angry chatter of anti-aircraft guns, and the silent, terrifying fall of incendiary rain, which glittered like malevolent jewels. The capital became a target of calculated, protracted terror. For the Royal Air Force, the challenge of the night was infinitely more difficult than the day. In the daylight, the long-wave chain home (CH) radar had provided just enough early warning to scramble the fighters. But in the blackness, electronic chaos reigned. The CH signals were too long and crude for precise night interception, unable to give the controllers the tight resolution needed to vector a fighter onto a single, fast bomber. Searchlights, though beautiful in their geometric choreography, were tragically inefficient, carving the dark with cones of light that rarely found their mark. RAF controllers, hunched over their glowing, primitive maps and radar screens, felt the strain of the hunt. They were fighting blind, relying on blurry blips that flickered, merged, and often vanished altogether, leaving them to guess where the next wave of destruction would fall. The stakes were existential. If the Luftwaffe could maintain this nocturnal pressure, methodically destroying ports, starving factories of supplies, and eroding morale with impunity, Britain would inevitably be starved and bombed into submission. The only hope was to find a way to see the enemy in the dark, or, better yet, to find a way to blind the enemy completely and steal back the element of strategic surprise. This necessity drove the UK's most brilliant scientific minds into the darkest corners of electronic theory. Across the Channel, the Germans felt absolute and total confidence in their methodical, technological approach to defense. Their territory, and the vast occupied zones, was protected by the Kammhuber Line. Named after Generalmajor Joseph Kammhuber, the line was not a static linear trench or fortification, but a sophisticated, flexible, three-dimensional defense grid that stretched from Denmark down to the French border. It was a masterpiece of electronic coordination. The line was composed of a rigid series of interlocking electronic boxes, or Himmelsbedden sky beds, each one a fully coordinated, autonomous defense sector. Every box was a fortress of technological control, engineered for maximum lethality. Within each defined sector, three key electronic and kinetic elements worked in deadly concert. Freya radar, the long-range early warning sentinel. Operating at a 2.5-meter wavelength, Freya was powerful, capable of spotting incoming aircraft up to 125 miles away, providing the macro picture. Würzburg radar, the precision instrument. The Würzburg, with its distinctive 2-meter parabolic dish, operated on a much shorter wavelength, around 50-60 centimeters, granting it incredible angular accuracy. It was the crucial ground-controlled interception (GCI) instrument and gun-laying radar. Night fighters, dedicated knockjagged squadrons, often flying heavily armed Messerschmitt Bf-110s, waited on the ground, ready to be vectored precisely into position by the radar controllers. The interception process was a deadly electronic ballet. A GCI controller, often sitting in a darkened, claustrophobic bunker, used one Würzburg set to track the inbound RAF bomber and a second Würzburg set to track his own night fighter. He would talk the pilot onto the target until the fighter was close enough for the pilot to see the bomber's silhouette, the chillingly effective, 2 Würzburg technique. Germany's radar hunters had one great asset: numbers in a methodical, centralized system. Hundreds of stations tracked the skies with remarkable precision. But this quantity masked a fatal blind spot, a profound weakness embedded in the very architecture of their electronic mind: a flaw born not of incompetence but of the very need for efficiency and standardization. The analysts at the highly secretive telecommunications research establishment TRE knew that the radar returns from an aircraft were complex. But the vulnerability they discovered was not in the physics of reflection, but in the engineering of repetition. British intelligence, specifically the analysts of the Y Service, Signals Intelligence, and scientists like Dr. R.V. Jones, had been obsessively listening to the electronic whispers of the Reich. They realized that due to the inexorable demands of wartime mass production and standardization, the entire German radar network was operating with a dangerously uniform, predictable electronic rhythm. The key lay in the pulse repetition frequency (PRF). Every radar set broadcasts pulses at a uniform, precise rate. The time it takes for a pulse to leave and return determines the range. For a clean, stable image, the PRF must be constant. The TRE scientists, poring over captured equipment, discovered that the PRFs of the Key-Freya and Würzburg sets, while technologically advanced, were also locked in a tight, narrow band across the entire Kammhuber line. This was the Nazi superweapon that worked too well. The desire for seamless, interchangeable equipment across the vast German front had created a singular, collective electronic weakness. Dr. Jones realized the disastrous implication. The whole network was a single, vast, predictable clockwork machine. If that rhythm could be interrupted, overloaded, or, most destructively, temporarily synchronized against the operator's perception, the whole grid might be tricked into silence. The British weren't fighting the aircraft, they were fighting the clock itself. The revolutionary idea was to use a powerful counter-signal that was precisely timed to mimic the incoming German PRF. This would overload the receiver with a false, self-generated echo, drowning out the real aircraft. Then, by introducing a small, controlled timing drift in the jamming signal, they could create an electronic illusion that the target had simply ceased to exist, fading smoothly from the screen as if it had flown below the horizon. They would make the operator believe the air was clean when, in fact, the sky was full of electronic noise and a very real bomber. The plan was codenamed Operation Null Hertz, to create zero electronic reality. To execute this delicate electronic assassination, the RAF needed the perfect platform, an aircraft that was not just fast, but stealthy and capable of sustained high-altitude penetration. The choice was the de Havilland Mosquito. Nicknamed the Wooden Wonder, the Mosquito was a twin-engine marvel built primarily of balsa wood and plywood. It was the technological antithesis of the metal-heavy, mass-produced Allied bombers. Its wooden structure made it astoundingly fast, routinely clocking speeds over 400 miles per hour, but its wooden airframe provided an unexpected, crucial advantage. It possessed a naturally low radar cross-section. Wood absorbs and scatters radar energy far less efficiently than aluminum skin. The Mosquito was a ghost even before the electronics were switched on. RAF planners immediately seized on the Mosquito's unique attributes for Operation Null Hertz. Instead of sending a conventional, destructive formation, they would send one lone Mosquito, penetrating the deepest and most sensitive sector of the German network, equipped with experimental jamming gear. The crew selected had to be more than just talented aviators, they needed to be scientists under fire. Squadron leader Mark Shadow Easton Pilot, known for his almost unnerving capacity for precision flying, especially maintaining perfect altitude and attitude under immense pressure. His callsign Shadow reflected his ability to fly precisely in the dark, relying on instruments alone. Flight Lieutenant David Clocks Bennett Navigator Operator, a former electrical engineering student whose technical acumen and ability to manually tune sensitive radio gear under stress were unparalleled. His nickname Clocks referred to his obsessive focus on timing and precision. The mission required perfect timing, nerves of absolute steel, and a single, near-impossible gamble, using technology to create a credible lie, making the Germans believe there were no aircraft to track at all. The electronic apparatus that made the deception possible was a prototype jammer, a bulky, complex assembly of vacuum tubes, sensitive resistors, and high-powered transformers housed in a black, custom-built casing that occupied the Mosquito's entire bomb bay. This was the unheralded ancestor of the powerful mandrel jamming system. The black box had two integrated functions that Bennett would control in sequence. Broadband noise, a first-stage function to broadcast a powerful, sustained band of electronic static across the known German radar frequencies, creating a massive, confusing clutter on the operators. screens, the initial smokescreen. The null Hertz trick, synchronization and drift, this was the genius. Bennett would first tune the jammer's high-power oscillator to perfectly match the incoming Würzburg PRF, effectively overloading the receiver with a self-generated electronic echo that precisely mirrored the German pulse. The real return from the Mosquito would be drowned out. Then, using a tiny vernier dial, he would introduce a minuscule, gradual timing drift in the jamming signal. This drift would cause the false, strong return on the German screen to slowly, smoothly fade out, mimicking the natural decay of a signal when an object drops below the radar horizon or flies out of range. To the German controller, the target wasn't just being jammed, it was vanishing in a smooth, predictable, and therefore credible way. The rigidity of German engineering, the very perfection of their standardized PRF, was about to be exploited by a subtle, perfectly timed lie. Easton and Bennett spent weeks in a darkened, radio-isolated hangar at Trey, simulating the mission conditions and practicing the demanding choreography. They were training not for evasion, but for electronic psychology. They practiced flying a complex, 5-point turn pattern on a training range while Bennett executed the null Hertz sequence. The tolerance for error was measured in microseconds. Tune too fast, and the jammer would register as a burst of crude, ineffective noise. Tune too slowly, and the real target would momentarily appear on the screen, exposing the entire deception. The calibration was critical. They had to match the pulse frequency of a radar beam traveling at the speed of light, then deliberately induce a tiny, controlled error. The mission profile was set. A deep penetration of the most heavily defended North Sea coast sector, a hub where multiple Freya and Würzburg installations were known to cross-reference data. The objective was to fly directly toward the most powerful Würzburg site, initiate the jammer, fly for 20 critical minutes while causing maximum confusion, and then turn off the system and escape, leaving behind only the ghost of a technical fault. They were not just risking their lives, they were risking the biggest intelligence secret the RAF possessed. Had they been shot down, analysis of the recovered black box would have revealed the German PRF vulnerability instantly, allowing Kamhuber to change the system settings and neutralize the entire Allied electronic effort before it even began. This was not a military raid, it was a scientific sacrifice. The night of Operation Null Hertz was bitter cold, with low cloud giving way to clear, freezing air at high altitude. At 2100 hours, the Mosquito, painted in dull night black, slipped away from its East Anglian airfield. Easton flew a masterful low-level course, skimming the tops of the white-capped waves in the North Sea, pushing the Mosquito close to its structural limits to remain under the long-range sweep of the coastal Freya early warning radars. The air in the cockpit was tense, the silence between the crew broken only by the cold hiss of oxygen and the rhythmic pounding of the Merlin engines. As they crossed the enemy coastline near the Frisian Islands, entering the first layer of the Kamhuber line, Easton pulled the stick back, initiating a rapid, steep climb to their mission ceiling of 28,000 feet. "We're in range, clocks," Easton's voice crackled over the intercom, clipped and steady. "Give me the sound." Bennett, hunched over the black box, flipped the highly sensitive sensor receiver. Instantly, a high-pitched, steady whine filled their headsets, the unmistakable, relentless, monotonous heartbeat of the German Würzburg PRF. It was the sound of the enemy's focused, electronic attention. 150 miles inland, in a reinforced concrete bunker known as Flugmeldestellung 8, Oberleutnant Klaus Richter stared intently at his Würzburg screen. Richter was the epitome of the methodical GCI controller, whose universe was the flickering green cathode ray tube. Suddenly, the screen went savage. The clear blip of the high-speed target dissolved into a wave of thick, flickering snow, pure, brutal electronic noise. The entire scope was swallowed by a deafening storm of static. Jamming. Heavy, focused noise jamming. Richter barked, his face pale in the scope's green glow. "This is not window. This is strong, sustained energy. Check the filters." Richter and his technician frantically tried standard countermeasures, but the noise remained, an impenetrable electronic shield. Then came the critical maneuver. In the Mosquito, Bennett engaged the main jammer and began to turn the tiny vernier dial, initiating the pulse synchronization and drift. He was matching the German PRF, canceling out the real signal, and then slowly fading the resulting false signal. On Richter's screen, the thick noise band that defined the target began to thin and recede. The strong signal that was overloading the scope began to smoothly diminish. Because the jamming pulses were perfectly timed to cancel the return and then drifted, the signal behaved exactly like an aircraft banking away at high speed and rapidly falling out of range. For an agonizing, unbelievable minute, the blip, and the associated jamming, disappeared entirely. The spot on the screen where the large, loud target should have been was now chillingly, impossibly empty. Richter, it's gone clean. The return has vanished. The technician stammered. Würzburg shows nothing. No noise, no return. Richter stared, his world tilted completely off its axis. The Freya report still showed something was in the sector, a source of heavy electronic interference, but his precision Würzburg was silent. The only rational conclusion was technical disaster. It is a catastrophic equipment failure, Richter declared, his voice tight with controlled panic. Report the Würzburg is offline. Magnetron failure in Sector Gamma. We have lost the track. The Nazi superweapon, designed for perfect uniformity, had just convinced its own operators that it was broken. The lie had been told, and the German mind had believed its own machine was broken. For the next 20 minutes, the Mosquito played its ghostly game. Easton maintained precise altitude and course, a pre-calculated zigzag designed to maximize exposure to multiple Würzburg sites. Bennett continually adjusted the black box, creating perfectly timed false voids, brief, engineered moments of electronic silence, that convinced the German operators across the entire sector that their tracking was failing uniformly. Across northern Germany, dozens of operators watched flickering screens as blips began to vanish, merge, and then, terrifyingly, disappear in their most critical defense zone. Calls flew across the landline network. Status of Würzburg 4. Are you experiencing atmospherics? We have lost all tracks in Sector 7 Bravo. The rigid German clockwork machine, the backbone of the Kammhuber line, had seized up in a localized electronic panic. Fighter controllers were misdirected, sending precious night fighters on wide, blind patrols, convinced their instruments had failed. Flak batteries, relying on the Würzburg input, remained chillingly silent. The risk for Easton and Bennett was absolute. They were flying through enemy flak zones, relying entirely on their speed and the electronic lie for cover. The mission demanded not evasion, but exposure and control. The courage required to fly toward the known center of the enemy's defense, shielded only by a perfectly tuned dial, was unprecedented. At 21:55, Bennett killed the power to the black box. The resulting electronic silence in the Mosquito's cockpit was immediate and profound. Easton turned south, dropping altitude and accelerating to their maximum speed for the sprint back across the channel. On the German screens, the electronic chaos instantly vanished, the targets and the noise reappearing in a sudden, jarring burst that only confirmed to the confused operators that their equipment had momentarily suffered an immense, localized technical breakdown, a short-lived fault. They had no idea a single, unarmed aircraft had just spent 45 minutes making a mockery of their defenses. When the Mosquito landed at RAF Weiden, the debriefing was held in stunned silence. The reconnaissance photos, combined with intercepted German radio traffic, service confirmation, proved it. The deception had achieved total tactical success. The German response during the Mosquito's penetration time had been incoherent, slow, and based on the false premise of hardware failure. The RAF had proven a simple, terrifying truth to the enemy: technology, no matter how advanced, could be tricked by a clever mind. The success of Operation Null Hertz was the birth certificate of modern electronic warfare and was immediately classified as one of the most vital secrets of the war. Its proof of concept confirmed that the systematic rigidity of the German radar network, the Superweapon, was its fatal flaw. The British RCM teams rapidly developed the technique into an operational system, Mandrel. Mandrel was essentially a refined, mass-produced version of the black box prototype, designed to be carried by multiple aircraft flying ahead of the main bomber stream. These aircraft would fly parallel to the main bomber route, creating a massive, continuous, 60-mile-long electronic screen or Mandrel curtain. This curtain of high power, precision-timed noise completely blinded the German Freya early warning radars and partially degraded the Würzburg fire control sets. The effect was profound. Instead of seeing a clear path for the massive, slow-moving bomber stream, German controllers saw only a vast, flickering band of electronic static. They knew something was there, but they could not determine its size, course, or speed. The Mandrel Curtain restored the element of surprise to the Allied bombing campaign, forcing German night fighters to rely almost entirely on visual sighting or on unreliable ground observers. This was the first major step in what became known as the Battle of the Beam. For the German High Command, the periods of sustained, localized radar blackout became inexplicable and infuriating. General Kammhuber demanded answers, convinced that the failures were due to internal espionage or, more likely, a completely unknown atmospheric phenomenon. They simply could not accept that the most advanced electronic defense system in the world could be fooled by a single, carefully tuned dial. Controllers like Oberleutnant Richter became figures of mounting paranoia. Their reports of the phantom void, the moment the target blinked out of existence, were initially dismissed as fatigue or operator error. But as the phenomenon spread across the sector, high-level engineering teams were mobilized. They checked cables, replaced sensitive magnetrons, calibrated hundreds of dials, and even tore down entire Würzburg units to search for the mythical fault in the German design. The critical mistake was the assumption of hardware failure. The Germans never suspected they were being deceived by an electronic counterpulse precisely timed to the PRF they believed to be their greatest strength. The diversion of these resources, the time of brilliant engineers, the strategic metals for replacement parts, the hours of high command attention, was an unquantifiable but massive win for the Allies. The lie was destroying German defense capacity more effectively than any conventional bomb. The Germans were not stagnant. They eventually began to adapt, realizing the enemy was utilizing some form of airborne jamming. Their engineering response was to turn the hunter into the hunted by developing airborne receiving equipment. The primary answer was the Naxos receiver. This device was fitted onto German night fighters, allowing them to home in on the source of the Allied radar transmissions. If the enemy was using powerful radar, like the Allied H-2S bombing radar, or, more pertinently, powerful jamming, like Mandrel, the Naxos could guide the fighter directly to the signal's source. The war then became a battle of emission control. Allied aircraft had to constantly balance the need to jam the German ground stations, Mandrel, with the need to avoid giving away their own position to the German night fighters equipped with Naxos. It became a tactical chess match. The Mandrel jamming created a necessary shield for the bomber stream, but that shield was also a high-power beacon for the enemy hunters. Every move required a counter-move, escalating the electronic struggle with ferocious speed. The success of Nullhertz led to the deployment of the next great electronic secret window known to the Americans as chaff. This involved dropping massive quantities of thin, reflective aluminum strips, cut to precise lengths to resonate at the German radar frequencies. Nullhertz had created a single, targeted lie. Window created mass electronic madness. By dropping tons of chaff ahead of the main bomber stream, the Allies could make the German radar screens believe the sky was suddenly filled with thousands of aircraft, totally saturating the limited bandwidth of the Würzburg and Freya systems. The German GCI controllers, faced with a screen full of electronic fog that rendered their precision tools useless, were forced to fall back on desperate visual techniques. The uniform nature of their PRF, once again, allowed the Allies to tune chaff for maximum, system-wide effect. The deployment of chaff was the ultimate expression of the silent lie principle, overwhelm the enemy's sensors with so much deceptive information that they lose the will and the ability to distinguish reality from illusion. The Nazi superweapon, built for precision, was now drowning in its own rigidity, a victim of its own success in standardization. 15. The legacy. The permanent war of the spectrum. The solitary flight of the Mosquito on Operation Nullhertz was the catalyst for a permanent revolution. It fundamentally changed the relationship between attacker and defender, proving that control of the electromagnetic spectrum was as vital as control of the air or the sea. The war was no longer fought solely by pilots pulling triggers, it was fought by scientists manipulating radio waves and engineers designing countermeasures in the constant, frantic race for electronic superiority. The speed of a fighter was now less important than the speed of a signal. The power of a bomb mattered less than the power of a counter-signal. The Ghost Rider of the Mosquito proved that in the electronic fog of war, the enemy is most vulnerable when he trusts his instruments, and that those instruments can be made to betray him. The silence engineered that night in 1940 guaranteed that the war in the air would never again be a purely physical contest, but a continuous, escalating battle of wits and waves. The Nazi superweapon, the unified Kammhuber line, worked too well for its own good. its perfect electronic consistency made it perfectly vulnerable to a single, powerful, and brilliantly timed lie.